third molecule we have is BeCl2, and the first thing we need to do is find a Lewis dot structure. To do that, we need to find how many valence electrons this has. So we received 7 valence electrons from chlorine and 2 from beryllium, which gives us a total of 16 valence electrons. And then we distribute those 16 valence electrons to each of the atoms to form octets on each one, except beryllium, because it's an exception and it can't have 8 electrons. It can only have 4. So to check to make sure that our Lewis dot structure is correct, we'll check the formal charges, and we see that the formal charge of the Cl's are both 0, and the formal charge of Be is also 0, so we know that this is the right Lewis dot structure. And the partial charges for these atoms is both Cl's have a partial negative charge, and beryllium has a partial positive charge because Cl has a higher electronegativity. And the dipoles go from beryllium to chlorine because they go from the slightly positive to the slightly negative charge atoms. And then to find our net molecular dipole, we have to again look at the electron domain geometry. And to do that, we see that this has 2 domains and 0 non-bonding pairs of electrons. So this is a linear geometry. So we can draw that out to look like this. And we see that there are 2 dipoles here, so if we put those in vectors, we see that they cancel each other out. So because they cancel each other out, we can say that this molecule is nonpolar.